Good day, ladies and gents. Welcome to BK Mathematics. And today, let's try to look at indices. Now, in indices, we have series of laws that we are going to learn today. After which we are going to solve series of examples on indices. Now, the first law that we are coming to learn, these are the laws of indices that if you want to solve millions of examples and to unlock indices problems, these are the steps that we are going to take. Okay, let's just try to learn the laws of indices first. Now, the first law, let's say these are the laws of indices. We say laws of indices. Now, the first law that we are coming to look here first, we say multiplication law of indices. This is the first law that we have to look at. Now, looking at this law, it's stated as whenever you have the same base, you just need to take one base and add the powers. That is exactly what multiplication law of indices is trying to say. Now, from this, what this one is trying to say, we just need to take one. Let's say, for instance, you have base A, it's raised to the power x, multiplying by base A also raising to the power y. Now, for the fact that they are having the same base, what are we to do here is we just need to take one base of them, then we add the powers. Okay, now adding these two powers, you're going to have x plus y. Okay, so this is what multiplication law of indices is trying to say. Okay, hope it is clear. That's the first law of indices. Let's look at the second one. Now we say division law of indices. It's another law. Now, division law of indices stated as whenever you have the same base, you just need to take one base of them and subtract the powers. For instance, having a raised to the power m divided. This one symbolizes that it is division law. Then you are having another base a raised to the power n. For the fact that this is base a, this is also base a, and you are having division sign between them, what I have to do here is you will take one base of them, then we subtract their powers. That is, we say m minus n. It can also be like having x raised to the power y divided by x raised to the power n. It can also be represented in this form. Okay, now to apply division law of indices from this point, we take one base of them, that is x raised to the power, because this is x, this is also x. We take one x, then we subtract their power. This one becomes y minus n. Okay, this is what we refer to be division law of indices. Now let's look at the other law. We say the third law, that is, we say and zero index law of indices. This is another law which in most cases people find it very, very difficult to arrive to the answer. This law stated as whenever you have or a letter or a number raised to the power 0, that number is equal to 1. But like in case, for instance, having x raised to the power 0, we say this is equal to 1. And if we say 2 raised to the power 0, we say this is equal to 1. But like in case if you are having 0 raised to the power 0, for the fact that this is 0 raised to the power 0, you will not apply 0 index law of indices. 0 index law of indices will not work here. Okay, now for this case, your answer should be undefined. Take note, this is very, very important area. Most often, if you ask students to give answer 0 raised to the power 0, they will just say it is 1, not 1. Always, whenever 0 raised to the power 0, it is undefined. Okay, that is your answer. It is undefined. Then, the next law that we have to look at, we say subtraction law of indices. We say subtraction law of indices. Let's just try to learn them first. Now, this law stated as whenever you are having the same base, you just need to take one base of them and divide the powers. For instance, having base m is raised to the power n minus m raised to the power x. Now, for the fact that this is base m, this is also base m, and you're having negative sign between them, what I need to do here is we just need to take one base of them, then we divide their powers. That is, we say n divided by x. This is what subtraction law of indices is trying to tell us. You take one base of them, then you divide their powers. Let's look at the next one. This is the fourth law. Let's look at the fifth law. That is, we say power law of indices. This is another law, power law of indices. Now, this power is trying to tell us that whenever you're having a power and again raised to another power, what I need to do here is you just need to take one, you just need to multiply the two powers for you to have your final answer. For instance, having x raised to the power 2 and at the same time it is raised to the power a. Remember, this is base, this is a power, and this is also a power. Remember, this is power, this is also a power. And what I need to do here for you to have your answer, you just need to take to multiply these two powers for you to have your answer. Then we say this becomes x raised to the power 2 times a giving you 2a. Let's look at another example for power law. At times you will have something like this. This is x raised to the power y raised to the power m also. We know y is a power and m also is a power. For the fact that they are this and these are powers, what are we to do here is we take the base that we are given, then we multiply the powers. That is, we say y times m, then the answer then becomes my. Okay, so this is what power law of indices is trying to tell us. Okay, the next one, let's look at the sixth law of indices. Okay, we say product law. Let's look at the product law here. Product law stated as if you're having certain quantity in a bracket, what you have to do is just need to distribute them over the power that you are given. For instance, having x, y, z, and they are raised to the power m. Let's look at it. This is product rule. You're having certain variables in a bracket, then they are raised to a power. What I have to do here is we distribute this power over these factors. Then this one becomes x raised to the power m multiplying by y raised to the power m. We are distributing this power over these variables multiplying by z raised to the power m. This is what we refer to be the product law of indices. Just distribute the power, these factors over the power that we are given. This is product rule. The next rule that we have to look at before we start to solve examples, let's look at negative index law of indices. Let's say this is rule 7. Let's look at the next rule. That is rule 7. We say negative. We say negative index law of indices. This is very, very important also. Now for this, whenever you are given negative index of any number, it is equal to the reciprocal of that positive number. It is equal to the reciprocal of that positive number. For instance, having negative 2 raised to the power negative 1. Let's look at this one. Having something like this, now to reciprocate this one, is just like the reciprocal of this number, this positive number becomes 2 raised to the power 1. Also having x raised to the power negative 2, to reciprocate this one, just like 1 upon the reciprocal of the positive number of this one that you are given, that is x raised to the power 2. This is what we call negative index law of indices. The last one that we have to look at, let's say this is rule 8. Let's look at rule 8. Rule 8 is trying to tell us that we say fractional law. Let's look at the fractional law of indices. Now, fractional law of indices, this one stated as whenever a fraction is raised to a particular number or a letter, it is equal to the square root of that fraction. For instance, if you're having a raised to the power half, let's look at this. This a raised to the power half. It means this is equal to the square root of a. Okay, and if y raised to the power 1 upon 3, it is equal to the cube root of this letter. That is, we say the cube root of y. This is what we call the fractional law of indices. Okay, now upon explaining laws of indices, now we are coming to solve series of examples on how to treat these laws based on the problem that we are coming to mathematics. And let's also look at the example that we are given here. Like I explained in the previous video, that we are coming to solve series of examples on indices. These are the examples that we have here. Let's try to solve them one at a time for everybody to understand. Now the first example as we are giving here is, the first example as we are giving, we say A, we are giving 27 multiplying by 3 raised to the power minus 2 into, we are giving 8 also multiplying by 2 raised to the power minus 3. This is the first example as we are given, and let's try to solve it together. Now the first step, looking at these two numbers, let's just try to make this base, this 27, we are going to do it index form to equal with this one. Then we say this one becomes 3 raised to the power 3 multiplying by 3 raised to the power negative 2. Then into the same thing again, let's try to make this other base and this other base for them to be the same. Then we say 2 raised to the power 3 multiplying by 2 raised to the power negative 3. Okay, now the next step, what I need to do here is, for the fact that this and this are the same base, remember what I just explained in the previous video, that this is multiplication law, they are having the same base. What I need to do here is, we take one base of them, that is, we take base 3. Then what are we to do here? We just need to add their powers. That is, we say 3. Adding these two, meaning plus times minus, you are going to have negative 2. Okay. Into the same thing again, this and this are the same base. Let's just recall from the first rule of indices. We are saying if we have the same base, you take one base of them and add their powers. Then this one becomes 2 raised to the power 3 minus 3. Okay. Now the next step, let's try to simplify and see. We say 3 raised to the power 3 minus 2, we are going to have 1. Okay. Into 2, 3 minus 3, this one automatically becomes 0. Let's just recall from indices also. We are saying if a number is raised to the power 1, that number or letter just itself, that is, this one becomes 3 into. From indices also, what I just explained, I said if a number or a letter is raised to the power 0, that number is equal to 1. So automatically this is equal to 1. And we know 3 times 1, we are going to have 3. So this is the first example, that is A. Our answer becomes 3. Okay, let's look at the next one, that is B. We say B is giving us, let's look at B. We are giving 7 raised to the power 6 multiplying by 7 raised to the power 3. 7 raised to the power 3 divided by 7 raised to the power 4. From this point, let's just try to recall the laws of indices that we just treated. For the fact that this and this are the same base, and we just need to apply multiplication law of indices. Then we say 7. For the fact that this and this are the same base, we take one base of them and add. We say 6 plus 3, then divided by 7 raised to the power 4. Now adding these two numbers, we are going to have 7 raised to the power 9 divided by 7 raised to the power 4. For the fact that this and this are the same base, and this is division sign, we are going to take one base of them and subtract their powers. Then this one becomes 7. 9 minus 4, automatically this one becomes 7 raised to the power 5. Okay, and we know 7 raised to the power 5. Let's just try to simplify it, meaning we are going to multiply. We are going to say 7. This one equals 7 times 7 times 7 times 7 times 7. Now this is how you are going to do it for you to have your final answer. Now we know 7 times 7, this one giving you 49. This is also 49. Okay, now 49, let's say 49 times 49. You can say 49 times 21. Let's just try to do it quickly. Now multiplying these sets of numbers, 1 times 9, we know it is 9. And 9 times 4 giving you 4. 2 times 9, 18. We say 8 carry 1. 2 times 4, we know it is 8. 8 plus 1 giving us 9. Then adding this number becomes 9. This is 12, 2. And this is 9 plus the 1 carry, we are going to have 10. Meaning we are going to have 10,029. Meaning 7 raised to the power 5 giving us 10,029. So this is for B. Our answer equals 10,029 for B. Let's look at C also. Now for C, let's look at C and C. The question C, we are giving 2 raised to the power 3 multiplying by 2 raised to the power negative 4 divided by 2 raised to the power minus 2. Then everything raised to the power 2. It's very, very simple. You just need to use the laws of indices that we just treated. Okay, very, very simple. Now for the fact that this is multiplication law, what are we to do here is we take one base of them and add their powers. Then we say this one becomes 2 raised to the power minus 1 divided by 2 raised to the power negative 2. Everything raised to the power 2. Now for the fact that this is division law and we know what division law means, we just need to take one base of them and subtract their powers. Okay, then we say this one becomes 2 raised to the power negative 1. Subtracting this power, we are going to say minus 1 minus into minus 2. Everything raised to the power 2. Now simplify this one, we are going to say 2 raised to the power minus 1 plus 2. Then everything raised to the power 2. Simplifying this one, saying 2 raised to the power minus 1 plus 2, you are going to have 2 raised to the power 1 raised to the power 2. Now for power law of indices, let's recall for power law of indices. This is a power, this is also a power. And if you have these two powers, what I need to do, you just need to multiply the two powers for you to have your answer. Let's multiply the two powers. This one becomes 2 raised to the power 2. And we know 2 raised to the power 2, meaning we are going to say 2 times 2, then this one becomes 4. So this is the answer that we arrived for C. Now for D, if you want to solve D, let's say you are going to try this, please submit this C in the comment section. Okay. Example 2, we have solved example 1. I have explained the laws of indices. We treated example 1. Now let's get to treat example 2 also. We have to simplify. The first one says 27 raised to the power 1 upon 3 multiplied by 9 raised to the power 1 upon 2, everything raised to the power 2. Okay. Now we say solution. For the fact that we are given 27 raised to the power 1 upon 3 multiplying by 9 raised to the power 1 upon 2, then everything raised to the power 2. Now the first step that we have to take, let's just recall that this is fractional law of indices, and if it's fractional law of indices, we just need to use the cube root of this 27. Then we say the cube root of 27. Thank God I have explained fractional law of indices and other laws. Then 9 raised to the power 1 upon 2, meaning we are going to say the square root of this half. That is the square root of 9. Then everything raised to the power 2. And we know the cube root of 27 giving you 3 multiplying by the square root of 9, it is 2. Then everything raised to the power 2. We know 3 times 2 giving us 6 raised to the power 2. And 6 raised to the power 2, we know it is 36, meaning 6 times 6. And we know 6 times 6 giving us 36. Okay. Now this is our answer for the first one that we are given. Okay. Now for B, let's look at B. B, we are given 3, the cube root of 4 multiplying by 1 upon 9 root of 8 multiplying by the 12, the square root of 4 raised by negative 2, then everything becomes 1 upon 4. This is very, very interesting problem. Okay, let's look at it. Now to solve this one, let's try to reverse all these roots that we are given. Let's reverse them in their base form. Okay, so reverse this one, let's solve it one at a time. Now let's start with the cube root of 4. Now to reverse this one, we are going to have, this one becomes 4 raised to the power 1 upon 3. Okay, and we have reversed this one in its base form as this. Let's try to reverse this also in its base form. We have 1 upon the 9th root of 8. Reversing this one in its base form, we are going to have 1 upon, this one becomes 8 raised to the power 1 upon 9. We have reversed this one in its base form. Therefore, it can also be reversed as negative index law of indices becomes, this one becomes 8 raised to the power negative 1 upon 9. Okay. The same thing, let's reverse this one to its base form also. Reversing this one in its base form, we are going to have, since we have the 12 root of 4 raised by negative 2. Now this one becomes 4 raised to the power negative 2. Then everything becomes 1 upon 12. Now we have reversed this other one in its base form to this. Okay. Now let's just try to simplify now and see. This one has already becoming 4 raised to the power 1 upon 3 multiplying by this 1 upon the 9th root of 8. It's also arriving at 8 raised to the power negative 1 upon 9 multiplying by, instead of this, we have it already as 4 raised to the power negative 2 into 1 upon 12. Then we say everything becomes 1 upon 4. Now let's just try to simplify it and see. Now for the fact that we are going to have their basis for them to be the same, we are going to say 2 raised to the power 2 into, this one becomes 1 upon 3 multiplying by the same thing, we are going to say 2 raised to the power 3 into negative 1 upon 9. We know 2 raised to the power 3, we are going to have 8. Okay, multiplying by the same thing again, we are going to say this one becomes 4. Now the first thing that we are going to do here is we apply power law of indices. This is a power and this is also a power. What are we to do here is we multiply the two powers for us to have our answer. Then negative 2 times 1 upon 2, we are going to have minus 2 divided by 12. Okay, then everything goes to the power 1 upon 4. Okay, now the next step, let's get to simplify it. this is a power and this is also a power. What I need to do here is we multiply the two powers for us to have our answer. Then we say 2 raised to the power 2 times 1, we have 2 upon 3. Then we have multiplying by this a power and this is also a power. The having is 2 powers. What I need to do here is we say 2 raised to the power negative 3 divided by 9. Then the next step, what I need to do next, this we say 4. Let's try to make it for it also to be in base 2. We say 2 raised to the power 2 into minus 2 upon 12. Then everything is for 1 upon 4. Okay, now let's simplify it. We have, let's say we have 2 raised to the power 2 upon 3 multiplying by, now instead of this one, let's try to simplify it. We know 3 can divide 9 without any remainder. This one becomes 2 raised to the power negative 1 upon 3 multiplying by, simplify this one, we are going to say 2 raised to the power negative 4 divided by 12. Then everything raised to the power 1 upon 4. Okay, let's try to simplify this also and see. We say 2 raised to the power 2 upon 3 multiplying by 2 raised to the power negative 1 upon 3 multiplying by 2 raised to the power. Now simplifying this one, we know this 4 can divide this one without any remainder. That is, this one becomes negative 1 upon 3. Okay, then everything becomes 1 upon 4. Now to simplify this one, we say, let's try to find the LCM. Now we are coming to apply multiplication law of indices. This and this, they are the same base, and if they are the same base, what I need to do here is we take one base of them and add their power. This one becomes 2 upon 3 plus, for the fact that it's negative sign, we say negative 1 upon 3 minus 1 upon 3, then everything is equal to 1 upon 4. Now for the fact that we are having negative sign between this fraction, we are going to find the LCM. Then we say 2 raised to the power, what is the LCM between this one? It is 3. Then this one becomes 2 negative 1 minus 1. Then everything is about 1 upon 4. Okay. Now to subtract this one, we are going to have 2 raised to the power 2 minus 1 minus 1. You are going to have automatically, you are going to have 0 upon 3. Everything raised to the power 1 upon 4. Remember, this is power law of indices. This is a power and this is also a power. And if you are having 2 powers, what I need to do here is you multiply the 2 powers for you to have your final answer. Then automatically we are going to say this one becomes 2 raised to the power 0 times 1, you are going to have 0 divided by 12. And this one becomes 2 raised to the power 0 divided by 12, we know it is 0. Okay, remember from 0 index law of indices, we say if a number or a letter is raised to the power 0, that number it is equal to 1. Automatically our answer becomes 1 respectively. Example 1 and 2. Let's look at example 3. The first one says the root of 36x raised to the power negative 3 y raised to the power 3 divided by 4x raised to the power 3 y raised to the power negative 3. Let's try to solve the first one and see. Okay, now we say solution. The first one, we are given the square root of 36 x raised to the power negative 3 y raised to the power 3. Then everything becomes 4 x raised to the power 3 y raised to the power negative 3. This is the first one that we are given. And from this, we just need to use our laws of indices very well. The first step, we know this is square root, and square root it is equal to half also. Now this one becomes 36 x raised to the power negative 3 y raised to the power 3. Everything becomes 4x raised to the power 3 y raised to the power negative 3. Everything becomes half, because this square root that you are seeing, it is equal to half. Now the next step, we know this 4 can divide this 36 without any remainder. We know 4 goes into 36, giving you 9 times. This one becomes 9 x raised to the power negative 3 y raised to the power 3 divided by x raised to the power 3 y raised to the power negative 3. Okay, everything becomes half. Now from this point, we just need to make use of our laws of indices. This is x, this is also x, they are the same base. And what are we to do here is, for the fact that they are division law, we say this is 9 x raised to the power negative 3. When this one is moving, you are going to have negative 3 also, because from division law of indices, we are saying if you have the same base, we take one base of them and subtract their powers. That is exactly what I just did here. Then the same thing, this is base y, this is also base y, they are the same base. we take 1 base of them, then we subtract their power. Subtracting their power, this one becomes negative into negative 3. Okay, then everything raised to the power half. The next step, let's try to simplify it and see. Now we have 9 x raised to the power negative 3 minus 3, you are going to have minus 6 y raised to the power, we say 3 minus minus, you are going to have plus 3, then everything raised to the power half. Now it continues. Also we say 9 raised to the power x raised to the power 6, y raised to the power 6 also, then everything becomes half. Okay, now from product law of indices that I just explained in the first video, we say if you're having a power, this product rule that we are coming to use here, we just need to distribute this power over each factor. Okay, then we say 9 raised to the power half multiplying by x raised to the power negative 6 raised to the power half multiplying by y raised to the power 6 raised to the power half. Okay, now we have distributed this half over these factors. Now let's just simplify now for us to arrive at our answer. Then we say we know half means square root. The square root of this 9, we know it is 3 multiplying by, this is a power and this is also a power. What are we to do? We apply power law of indices, and we know power law of indices stated as if you have a power and again raised to another power, you just need to multiply the two powers. This one becomes negative 3. Okay, multiplying by the same thing again, this is a power, this is also a power, and if you are having the same powers, what I need to do here is you multiply the two powers. This one becomes y raised to the power 3. Okay, now for the fact that this is negative index law of indices that we are coming to apply because it is having negative sign, then this one becomes 3 into 1 upon the negative reciprocal of this positive number that we are given now, that is x raised to the power 3 times y raised to the power 3. Therefore our answer then becomes 3y cubed upon x raised to the power cube respectively. So this is our answer that we have for the first one. Let's look at the second one also. Let's try to solve the second one and see. Okay, now the second one, we have to evaluate 6 into 1 minus 7 upon 16 into negative 1 upon 2 multiplied by 2 raised to the power 1. Now this is past question y. Let's try to solve it also using laws of indices. Now the first thing, we know we have to find the LCM between these points. Okay, now we say the LCM between 1 and 16 giving us 16. This is 6. Now 1 into 16, we know it is 16 times. 16 times 1, we know it is 16. Negative 1, 16 into 16, it is 1 time. 1 times 7 giving us 7. Then everything raised to the power negative half multiplying by 2 raised to the power negative 1. Simplifying this one, we know 16 minus 7. Subtracting these numbers, we say 6 into 16 minus 7, we are going to have 9. Okay, 9 divided by 16 raised to the power negative half multiplying by 2 raised to the power negative half. Now from this point, what are we to do next here is, if you want to change this negative sign to apply the negative reciprocal of this positive number, let's say it continues from this point, we have it as 6 into 9 upon 16, everything raised to the power negative half multiplied by 2 raised to the power half. Now what I need to do here is, we want to change this negative reciprocal of this positive number. Then what I need to do here, we say 6 into 16 divided by 9. This one becomes half multiplied by 2 raised to the power 1. Okay, negative 1. We know half means square root, and we know the square root, we are going to say 6 into the square root of 16 divided by the square root of 9 multiplying by 2 raised to the power negative 1. We know the square root of 16, it is 4, and the square root of 9, it is 3. Then this one becomes 6 into the square root of 16, it is 4 divided by 3 multiplying by 2 raised to the power negative 1. Now for the fact that this 3 can divide this into 2 remainder, we say 3 here 1 time into 6, it is 2 times. Then this one becomes 2 into 4 multiplying by 2 raised to the power negative 1. 2 times 4, we know it is 8 multiplying by 2 raised to the power negative 1. And for this 8 and this 2, for them to be the same, we are going to do the index sum of this 8. That is 2 raised to the power 3 multiplying by 2 raised to the power negative 1. For the fact that this and this are the same base, and what have we to do? We applied multiplication law of indices, and we know multiplication law of indices stated as whenever you have the same base, you just need to take one base of them and add their power. This one becomes 2 raised to the power 3 minus 1. This one becomes 2 raised to the power 2. And we know 2 raised to the power 2 is equal to 2 times 2. 2 times 2 giving us 4. So this is the answer that we just have for B. Okay, thank you for watching. Make sure you share for others to benefit. Okay.